0 over infinity. Well, we've got infinity divided by infinity, so I think we're kind of stuck there. Now we have to go back and figure something else out. So one of the things we're always trying to do here is somehow get rid of that dividing by infinity, because that's not going to work. This is kind of, I'm just going to, this one is magical math manipulation as far as I'm concerned for you guys. I would never give you one like this because it's just too much algebra. So what I'm going to do here is I'm going to factor out of the numerator 2 to the x. And whoa, how did I do that? That's kind of one of the, not necessarily sure that you would catch how that happened. So let's just kind of go to here. And let's say, well, if I factor 2 to the x out of here, that means I'm going to have, oh, that's not right. Oh, here we go. Sorry. Got to have the same base, right? So 2 squared is the same thing as 4. So now I've got 2 squared. So I've got 2 to the negative 2x. And if I factor the 2x out of there, that means I've got to subtract an x out of there. Right? Yeah, I think so. So that's 2x times 1 minus 2 to the negative 3x, which then I can separate that 3 back in and say it's 2 to the x, 1 minus 8 to the minus x. So I really had to work on that mess to get that. And then I don't even like what I did next, which was this. The limit as x approaches infinity of 2x over 3x times 1 minus 1 over 8 to the x. That part I don't mind. It's the next, well, let's just keep going. Limit as x approaches infinity of 2/3 to the x. Now I can do that. That's just good old fraction stuff. If you have fractions to the same power, you can put them all in one fraction. And now when I plug this in, well, let's do one more thing. Let's make it multiplication. Limit as x approaches infinity of 2/3 to the x times the limit as x approaches infinity of 1 minus 1 over 8 to the x. So if I take a fraction to an infinite number of exponents, large, what's going to happen to that fraction? 2/3 to the 1/millionth power is basically 0. Yeah, any fraction less than 1 when you explode it up is going to, its limit is going to be 0. And that's where I have a problem, because you don't really have that information, and to assume you have it would be not very fair. And then here we're going to have 1 minus 0, because as x gets bigger, that 8 to the bigger is going to explode, and so we're going to have 0, because we're going to squish down. And then we have 0 times 1, which is 0. That would be like an extra credit on the take-home. And then the last one, I don't know what I was thinking. Again, I printed out the wrong one. This is not on the other one. But that's okay, because we'll walk through it and talk about the manipulations anyway. because I think you should learn something from this. So the hint there is substitution. Well, if I just throw that in, I end up with 1 minus 0 to the infinity, and we're told that 1 to the infinity is indeterminate. I don't really understand why that is, but we're told that it's indeterminate. And so now we're going to do some really interesting things. And the only reason that I caught this was looking at some definitions. I'm going to do a substitution here. Now I typically wouldn't use H, but there's a reason I'm using H. It's because we're headed toward a definition. Okay, now I want to talk about, well, as 5 over x, as x goes to infinity for 5 over x, where's h going?
0.
Why?
Because anything constant over infinity equals 0 versus the x-axis.
Good. So as x over infinity, as x goes to infinity, 5 over infinity goes to 0, which means that must mean that h goes to 0. So as this goes to infinity, it's going to force this to go to 0. That is one of the really, really common manipulations that we use when we're stuck with no other idea what to do, is we say, well, let me change a fraction into a whole number, and then I can go to, instead of going to infinity, I'm going to 0. Now I'm going to throw a definition up here on the board for you. And go through some manipulation kind of stuff here and say, well, let's algebraically manipulate this. Right, flip those over. I'm trying to get x by itself here. So x equals 5 over. So now let's just look at our guy that we started with, and let's plug our substitutions in there. Do you notice how I'm not losing this little thing? Please do not lose the limit. If you want to algebraically manipulate an expression, that's fine. But go do it somewhere else than right in your process. Because if you're right in your process, you have to keep track of that that's a limit. And definitely we want to do it here since we've made some substitutions. So now I've got 1 plus 5, 5 over x is going to be h. To the x power, which we said x is now 5 over h. So do you see a connection between that thing and the definition of E? Now, how would I expect you to pull that out of your head? Well, that's why this was too hard. So that and that only differ by this thing. So that means this must be e to the 5th. So I'll be sure and not print this one again. I'll label it as too hard. And you guys won't be overwhelmed. So let's talk about the exam. Exam. Let's see. There will be a picture of a function, and there'll be various questions about limits as x approaches the number. We've done some of those. The limit as my function approaches 3 Well, as I go from the left, it's 2. As I go from the right, it's 2. So I can say the limit as x approaches 3 of my function is 2. A variety of questions like that, like 11 of them? Yeah, but they should be quick and easy ones. You should be able to just read stuff off the graph, and it should take you almost no time at all. And then, there's a complete the table to determine what the limit is. So bring a calculator, for sure. Because really, all I want you to do is put those numbers down there. So limit, here's the limit, find the value of the limit by using a table. In other words, you're going to be computationally heading to the point from that direction and that direction. Explain what the following statement means. Let's see. What of those statements might I ask you about? Epsilon delta definition. Squeeze theorem. Will it be explain the squeeze theorem in words? I think there's use a couple of theorems to do some things. That makes sense. But again, I won't just say use the extreme value theorem to blah, blah, blah. I will say, here's the extreme value theorem, here's what it says, I'll type the whole mess out, and then I'll say, use that to do this. Finding limits, that's a lot of what's on here. And most of them, some of them are going to be just plug and chug because I want to make sure that you remember to do that. So there's going to be a couple that are going to be just 30-second questions because plug it in and see what the value is. And then there's going to be some that are going to be the indeterminate form, and so you'll have to use some algebra on it. And then there'll be some that will be just the recognition kind of things. So for instance, so you should, that's basically a plug and chug, right? Because you're going to say, oh, that's 1/0, so that's plus or minus infinity. So I just need to look at it from the left side and from the right side and see what my values are. So if I say x equals -1, then the value is -1, which means that it goes to negative infinity from the left-hand side. And if I just say x is 1, then I've got 1, which means that from the right-hand side it goes to positive infinity. And so we'd have to say, well, it doesn't exactly have a limit. However, the limit from the left is negative infinity and the limit from the right is positive infinity. I think I'm going to skip any trigonometric ones just because we're flying through this so fast. And I don't want you to have to dig deep to find that information in your, well, it's like, how would you have ever recognized that as, oh, that's just E? I barely recognized it as E because I thought, that looks familiar. I'm not going to tell you that question because that would give the whole question away. It's a thought question. Find roots, discontinuities, and asymptotes of a function. So that kind of wraps up a whole bunch of skills that you have already had with some new ones. Roots, discontinuities, and asymptotes. So finding that they truly exist won't be that hard.